Hello students, this is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad. In this video, I will take you through the solutions of NTA test paper number 5, the mathematics part. Parth Tank Mathematics Institute is presenting to you the solutions of all the NTA test papers, so do follow them. The first question, if the value of 1 plus tan 1 into 1 plus tan 2 into 1 plus tan 3, so on and on up to 1 plus tan 45 is 2 raised to lambda, then the sum of the digits of the number lambda is. Now this is a very simple problem if we identify one thing, right? Take the first one and 1 plus tan 44, right? What is the advantage? Write tan 44 as tan 45 minus 1 in degrees, all in degrees, right? So this becomes 1 plus tan 1, and we know tan 45 minus 1 is nothing but 1 minus tan 1 by 1 plus tan 1, right? Because tan pi by 4 plus or minus theta is 1 minus 1 plus or minus tan theta by 1 minus or plus tan theta, right? We are using this identity. So this becomes 1 plus tan 1, and I take the LCM, it is 1 plus tan 1 plus 1 minus tan 1 upon 1 plus tan 1. Now these two are cancelled, and I see that the tan 1 and tan 1 are also gone, and I get 2. Okay, so that is 1 plus tan 1 times 1 plus tan 44 is 2, and the same thing can be done for tan 2 and tan 43, then 3 and 42, and so on up to 22 and 23. That is, you will have 22 pairs of 2. Okay, so 22, 2 raised to 22, and then finally you have the last term 1 plus tan 45. Now tan 45 is 1, so there is nothing but into 2. 1 plus 1 is 2. Therefore it is 2 raised to 23. Now they have said that the result is equal to 2 raised to lambda. So lambda is nothing but 23. Now the final question that they are asking is the sum of digits of the number lambda. That is, the digits are 2 and 3. So the sum of lambda's digits is 2 plus 3, 5. So the answer is option C, 5. Now very simple problem. Just identify that this can be rewritten in terms of tan 1. Okay, tan 45 minus 1. Question number 2. If summation of 5 plus 9 plus 13 up to n terms upon 7 plus 9 plus 11 upon up to n plus 1 terms is 17 by 16, then n is equal to. This is a direct arithmetic progression based problem. No shortcuts. Go for it, but do the algebra very carefully. The numerator, let us call it S1, is 5 plus 9 plus 13 for n terms, right? So there is n, a is 5 and d you see is 4. Arithmetic progression, both the numerator and the denominator are arithmetic progressions. So the sum to n terms of arithmetic progression is n by 2, 2a plus n minus 1 d, right? Alright, so the sum 1 would be n by 2, 2 into 5, 10, plus n minus 1, d is 4. Therefore, this becomes n by 2 into 10 plus 4n minus 4. Or you multiply and simplify this, it becomes 6 plus 4n, so 3 plus 2n, or 2n squared plus 3n. Let us go to the denominator. This is let's say this S2. This is an AP with A 7, D 2 and n plus 1 terms. So the equation becomes of S2 n plus 1 upon 2 times 14 plus n plus 1 terms. So n plus 1 minus 1 D is 2, right? Therefore I get n plus 1 upon 2 into 14 plus 2n. or the 2 can be cancelled. I get n plus 1 into 7 plus n, or this is n squared plus 8n plus 7. Okay, so I have S1 and S2. S1 upon S2 is 17 upon 16. Therefore, 2n squared plus 3n upon n squared plus 8n plus 7 is 17 by 16. Now form the quadratic equation, do the cross multiplications. So 32n squared plus 48n is 17n squared plus 136n plus 119, right? Okay, so simplifying this further, 15n squared minus 88n minus 119 is 0. Now this is quite simple to factorize because 119 has only two factors, 7 and 17, and then we need a minus 88. So 15 and 1 helps in this, right? So you get minus and plus. So this gives minus 105n plus 17n, which is minus 88n, right? So this implies n is either 7 or n is minus 17 by 15, which can be ignored. So n is 7. So the answer to this problem is n is 7, option A. Let us move on to question number 3. If 2 times f of xy is equal to f of x raised to y plus f of y raised to x for all x comma y belong to R, and f of 1 is 3, then the value of R to 10 summation f of R is equal to. Now this looks very tricky but simple if you take y is equal to 1, because they said this relationship holds for all x and y, right? So this equation becomes 2f x into 1 is f of x raised to 1 plus f of 1 raised to x. Alright. Now what we know is this is f of x, this is also f of x, so bring that here. 2 times f of x minus f of x is equal to f of 1. F of 1 is 3, so substitute 3 here, 3 raised to x. So I get f of x is nothing but 3 raised to x. Right? So summation R is equal to 1 to 10 f of R is nothing but 3 power 1 plus 3 square, 3 cube, so on up to 3 power 10. This is a geometric progression. First term 3, common ratio also 3, number of terms 10. Now sum of n terms in a GP is R raised to n minus 1 by R minus 1 when R is greater than 1, right? So therefore, sum Sn in this particular case is 3 times 3 raised to 10 minus 1 by 3 minus 1, or 3 by 2 into 3 raised to 10 minus 1, which is option A, 3 by 2, 3 raised to 10 minus 1. Very simple problem, just substitute x, y is equal to 1, and or you can do x is equal to 1 also. You would get f of x, and then from f of x you find that this is actually this summation is a geometric series. Question number 4. If 1 by 6 sin theta, cos theta and tan theta are in geometric progression, then the complete solution set of theta is, that is 1 by 6 sin theta, cos theta and tan theta are in geometric progression. What does this mean? If A, B, C are in GP, B square is A into C, right? These are in GP. Therefore, cos squared theta should be 1 by 6 of sin theta into tan theta. Now if I were to simplify this a little bit, this is sin theta into sin theta upon tan cos theta, and take 6 cos theta to the other side, I get 6 cos cube theta is sin squared theta. Now to make the solution simple, let's convert sin squared to cos squared. This is nothing but 1 minus cos squared theta, right? So the cubic equation we are left with is 6 cos cube theta plus cos squared theta minus 1 is 0. Alright. Now it's a cubic equation. I know it may look like it's a bit difficult to solve, but fortunately this equation is not so difficult to solve. Okay, all you have to do is find one root and then you can do synthetic division and find the other roots. Let us write the equation once more. Let us say it is 6x cubed plus x squared minus 1 is 0, where x is cos theta. Okay. Now, to find one root, just see x is 1 to nothing, but you can guess that x is 1 by 2 is a root here. Because if I put 1 by 2 here, I get 6 into 1 by 8 plus 1 by 4 minus 1 is 0, or 3 by 4 minus 3 by 4 is 0. It is 0 is 0, right? So 1 by 2 is a root to this equation. So how to find the remainder? I always use synthetic division. 6, 1, 0 minus 1 and 1 by 2, 0. So 6, 3, 4, so 2, 2, 1, 0. So the remainder is 6x squared plus 4x plus 2 into x minus 1 by 2 is 0. Okay. Now this gives us x is 1 by 2. Already we know that it is a root. And what about this? Let us try to find the roots of this. It is minus 4 plus or minus square root of 16 minus 4 into 8 is 48. And it's 4 into 12 basically. 4 into 6 into 2 is 48 by 12. So this is not allowed because the roots are imaginary. Okay. So x is 1 by 2 is the only solution, and since we took x as cos theta is 1 by 2 or cos pi by 3. So the general solution for theta is, we know if cos theta is cos alpha, theta is supposed to be 2n pi plus or minus alpha. Therefore in this particular problem theta is 2n pi plus or minus pi by 3. Alright. So the answer is, excuse me, two n pi plus or minus pi by 3, option B. Okay. So very simple. All that we have done is find the cubic equation, identify one root, and using that one root find the rest of the polynomial, the other factor, and that has imaginary roots. Therefore this only one root is a very simple solution. It is cos pi by 3, and therefore we know the solution is always 2n pi plus or minus alpha, the general solution. So the answer is option B, 2n pi plus or minus pi by 3. Moving on to question number 5. The value of the integral 0 to 1 square root of 1 minus x by 1 plus x dx. Now this is a very direct problem if we do the rationalization of the numerator, right? How do we do that? Multiply and divide by 1 minus x, square root of 1 minus x, excuse me. So what would this give us? This would give us 1 minus x in the numerator and square root of 1 minus x squared in the denominator. This can be split into two integrals. 0 to 1, 1 upon root of 1 minus x squared dx, and 0 to 1, minus 0 to 1 x by square root of 1 minus x squared dx. Now let's call this I1 and I2. What about I1? I1 we know is the integral of 1 by 1 minus x squared is sine inverse of x, of course, from 0 to 1. This becomes sine inverse of 1 minus sine inverse of 0, which is pi by 2 minus 0, pi by 2. So the first integral is pi by 2. Let's go to the second integral. We'll call this I1 minus I2. So the second integral is integral of x by square root of 1 minus x squared dx. Now if I were to take 1 minus x squared as u, du would be 2x minus 2x dx. So this can be written as, the numerator is nothing but minus du by 2, right, minus du by 2 upon square root of u. So this is minus 1 by 2 integral du by root u from 0, sorry, x's limits are 0 to 1. So u's limits will become, when x is 0, u will be 1, and when x is 1, u will become 0. So it is 1 to 0. Or I can make the limits change and drop the negative sign. So this integral is going to be u to the power minus 1 by 2. So u to the power 1 by 2 upon 1 by 2. So this is gone. This gives me 1 minus 0, which is 1. So my I2 is 1. Therefore, the final value I1 minus I2 is pi by 2 minus 1. Alright. So this is the solution. The answer is pi by 2 minus 1, option C. I'll just present to you one other technique also which you can use here, because many of you might have noticed that this can be simplified by using x is cos 2 theta, right? Because 1 minus cos 2 theta is 2 sin square theta. So the numerator becomes 2 sin square theta, denominator becomes 2 cos square theta, and dx becomes 2 sin 2 theta with a negative sign. And let us think about the limits a bit later, d theta. Now this is nothing but the whole expression is minus integral sin theta by cos theta, and there is a 2, another 2 sin theta cos theta, because sin 2 theta can be written as 2 sin theta cos theta d theta. Now all this is gone. So I have 4 sin square theta. So let me keep 1 2 outside, and this can be written as 2 sin square theta d theta. This is nothing but 1 minus cos 2 theta d theta. Right? After all this, now I can substitute here that I can integrate this and say minus 2 theta minus sin 2 theta upon 2. Right? Now I have to substitute the limits. First let me check the limit here. For x is equal to 0, 2 theta has to be 90 degrees, pi by 2, or theta can be pi by 4. So this is pi by 4. And when it is 1, cos theta has to be 0, so it's 0. So with this, it has to be pi by 4 to 0, pi by 4 to 0. Let us say, if I put 0 here, this whole term is 0. And if I put pi by 4 here, what do I get? So I get minus 2 into 0 minus pi by 4 here, minus sin pi by 2 by 2. Sin pi by 2 is 1 by 2. So if I multiply the 2 minus 2 inside, I get pi by 2 minus 1. The same answer as this. So there is also another way. There are different ways of doing. The answer is pi by 2 minus 1, option C. Question number 6. Limit based problem. Limit of p raised to 1 by x plus q raised to 1 by x plus r raised to 1 by x plus s raised to 1 by x by 4 the whole raised to 3x, x tends to infinity is. The first thing that I am going to do is take y is equal to 1 by x. Okay. Therefore, as x tends to infinity, y tends to 0. So the limit can be brought to x tends to 0, p raised to y plus q raised to y plus r raised to y plus s raised to y upon 4, 3 by y. Okay. What is the advantage now? See, this is a 1, because when x is 0, this becomes 1 plus 1 plus 1 plus 1. Sorry, y tends to 0. 4 by 4 is 1. 1 upon 1 to the power infinity, the indeterminate form. Right? So the easiest way, according to me, is let us call this limit L. Take log on both sides. Log L becomes, and you know that you can take the log inside. So it becomes log of this whole thing. So log of p power y plus q power y plus r power y plus s power y upon 4. The whole power 3 by y, and that 3 by y can be brought and written here. correct? Now this becomes a 0 by 0 form. When you put y is 0, this becomes 0, this becomes 1, log 1 is 0, 0 by 0. So use L'Hospital's rule, L'Hopital's rule. So it says differentiate the numerator and differentiate the denominator. How do we differentiate the numerator? Keep the 3. If you differentiate this whole thing, it has to become 1 by the whole term, right? P power y plus q power y plus r power y plus s power y by 4. And then you have to differentiate this term itself. Now that is interesting because p power y's differentiation is p power y log p, q power y log q, r power y log r, s power y log s upon 4. Remember here we have used the rule d by dx of a to the power x is a to the power x log a. Okay, we are using this expression. So now in this, if we substitute y is equal to 0 in the whole thing, the denominator becomes 1. The numerator becomes 1 into log p plus 1 into log q plus 1 into log r plus 1 into log s. Therefore, I can say that the this limit, when I apply y is 0 here, I would get L or log L is 3 into log p plus log q plus log r plus log s upon 4 by 1. Now what is this? 3 by 4 log of PQRS, because summation of logarithms is equal to the product of the arguments. This is log L. Alright. So now let us take this to the other side. This becomes log of PQRS the whole raised to 3 by 4 is log L. Raised to E on both sides, the limit is PQRS the whole raised to 3 by 4. Simple, using L'Hospital's rule. PQRS the whole raised to 3 by 4, option D. Moving on to question number 7. If 27 to the power 999 is divided by 7, then the remainder is. Now we know that such problems are based on binomial theorems. Okay. The first thing to identify is that 27 itself is 7 times 4 minus 1. That is, it is 7k minus 1. Now 27 raised to 999 is nothing but 7k minus 1 the whole raised to 999. Now the binomial theorem expansion would give us 999 C0 7k power 999 plus 999 C1 7k power 998, 7k the whole power 998, as and so on up to 999 C998 7k power 1. I'm sorry, here we missed one very important point. There is a minus 1 here. So you have to say it is minus 1 power 0. This becomes minus 1 square and so on, right? So here it becomes minus 1 power 998. And the last term is 999 C999 7k power 0 minus 1 power 999. Now the most important thing is that forget about the minus and the plus and all this here. All the terms here have some power of 7 power k, including this. This is 7k power 1, 7k square, 7k till 7k to the power 999. So the whole thing here is a multiple of 7. And then here I have 999 C999 is 1, this is 1, and this is going to be minus 1. So 27 raised to 999 is 7m minus 1. Now how to find the remainder here? Just add and subtract a 7. So that becomes 7m minus 7 plus 7 minus 1. This can be 7 times m minus 1 plus 6. So multiple of 7 plus 6. So the remainder is 6. So the answer is option D, 6. Very simple. Just write 27 as 7 times 4 minus 1. Important thing is to bring 1 or minus 1 here so that the whole thing can be handled easily. Let us move on to question number 8. If A is the matrix and A squared minus 4A plus 10I is A, then K is equal to how much? A very direct problem. So let us go ahead and calculate each of these terms. A squared is 1 minus 3 2K multiplied by 1 minus 3 2K. So this is 1 minus 6 minus 5 minus 3 minus 3K is minus 3 minus 3K, 2 plus 2K, and minus 6 plus K squared. And then minus 4A is going to be minus 4, 12, minus 8 and minus 4K. And 10I is going to be, what is 10I? 10, 0, 0, 10. So the left hand side is a summation of all these three. This is going to become minus 4, minus 5, minus 4, 10 is 1. Then minus 3 minus 3K plus 12 is 9 minus 3K. 2 plus 2K minus 8 is 2K minus 6. Minus 6 plus K squared minus 4K plus is K squared minus 4K plus 4. Now this should be equal to A, and A is nothing but 1 minus 3, 2 and K. Now see, 1 and 1 match, okay. How about 9? The equality of matrices says 9 minus 3K is minus 3, or minus 3K is minus 12, and K is equal to 4. Now K is equal to 4, substitute that here, that would satisfy this also. 2 times 4 is 8, 2K minus 6 will be 2 into 4 minus 6, which is 2, and that matches here. And K is equal to 4 will also match here. That is, if I have K squared, the equation is K squared minus 4K plus 4 is equal to K. Therefore, this is K squared minus 3K, minus 5K, K squared minus 5K plus 4 is 0, or K minus 1 into K plus 1, K minus 4 is 0. So K is equal to 4 is the root, but K is equal to 1 also comes, but K equal to 1 we know is not a solution for the other terms here, because K is equal to 1 would give 9 minus 3 is 6, and here we have minus 3. So therefore the only answer for this is K is equal to 4, option C. Question number 9. A piece of cheese is located at 12, 10 in a coordinate plane. Where is 12, 10? Let us say 12, 10 is here. A mouse is at 4, minus 2. 4, minus 2 going to be back here. And is running up the line y is minus 5x plus 18 to get closer to the piece of cheese. Well, minus 5x plus 18 is going to be a line this way. Okay. So let us say this line is minus 5x, y is minus 5x plus 18. At the point A, B, the mouse starts getting farther from the cheese rather than closer to it. That is, while it is running along this line, at one point it starts going farther away. It comes closer, then becomes farther away. That is, it reaches the minimum distance point, the perpendicular of course, and then after this point it starts getting farther away. So let us call this point A, B. The question is, what is the value of A plus B? So basically you are supposed to find the foot of the perpendicular, and once you find the foot of the perpendicular, you have this point, and then you find A and B. Now you know that from x1, y1 to a line ax plus by plus c is 0, the foot of the perpendicular, let's call it xp and yp, can be calculated using the equation xp minus x1 by a is yp minus y1 by b is equal to minus of ax1 plus by1 plus c upon without the square root a squared plus b squared. Okay, so here I have a point and I have the line also. The line is this can be rewritten as 5x plus y minus 18 is equal to 0. So I have a point and a line. So line is 5x plus y minus 18 is 0, and the point is 12 comma 10. Therefore, I can write the foot of the perpendicular xp minus 12 by 5 is yp minus 10 by 1 and minus axy. So 5 into 12 plus 10 minus 18 upon 5 square plus 1 square. So this xp minus 12 by 5 is yp minus 10 by 1 is 5 12s are 60 plus 1 10 70 minus 18 is 52. So minus 52 upon 26, which is minus 2. Therefore xp is 5 into minus 2 plus 12, which is 2, and yp is 1 into minus 2 plus 10, which is 8, right? So this is the foot of the perpendicular. A comma b is 2 comma 8. So a plus b is 2 plus 8, 10. So the answer is option B, 10. Very simple. All you have to find is the foot of the perpendicular. Now you can use the same equation to find the image. You remember, if you multiply this term by a 2 here, right? That is the image of a point on a line is twice this whole thing. Question number 10. Two medians drawn from acute angled vertices, let us say acute angled vertices of a right angled triangle intersect at an angle pi by 6. If the length of the hypotenuse of the triangle is 3 units, then the area of the triangle in square units is. Okay, let us draw a right angled triangle. Okay. Now the two medians of the acute angles, from the acute angle. So medians are the lines from the vertex to the midpoint of the opposite side, and from here to this midpoint. Okay. So if we say this whole side is A and this whole side is B, this is A by 2 and this part is B by 2, this also is B by 2. So we have a diagram like this, and they've given us that these two intersect at 30 degrees, pi by 6, and the hypotenuse is 3 units. Okay. Now with all this piece of information, how to find the area of the triangle? Very interesting problem. Now let us take this angle to be theta 1 and let this angle be theta 2. Okay. If this is theta 1 and this is theta 2, how much will this angle be? Because this angle would be theta 2 minus theta 1, right? You can make your own constructions. For example, you can make a parallel line here. If you make a parallel line here, this full angle is going to be theta 2 because corresponding angle, and this angle will be theta 1, and so the difference is pi by 6. So the main relationship we have here is theta 2 minus theta 1 is pi by 6. Let us do the tan of these two things. Alright. So what can we say about this? The left hand side is nothing but tan theta 2 minus tan theta 1 by 1 plus tan theta 2 tan theta 1. Yes, tan pi by 6 is 1 by root 3. Now what is tan theta 1? Tan theta 1 is nothing but a by 2 divided by b, the whole thing, right? This triangle, tan theta 1 is a by 2 upon b. So tan theta 1 is a by 2 upon b, so a by 2b. Now tan theta 2 will be a upon b by 2, which is 2a by b. Substitute them here. I get 2a by b minus a by 2b by 1 plus 2a by b into a by 2b is 1 by root 3. Now this 2 and 2 are gone. Here, this big, after taking the LCM is 2b, so multiply by 2, this is 4a, 4a minus a is 3a, 3a by 2b. So I get 3a by 2b and in the denominator I get 1 plus a squared by b squared, which after LCM is b squared plus a squared by b squared is equal to 1 upon root 3. Now let us take everything to the numerator. This becomes 3a into b squared by 2b into a squared plus b squared, with the b gone. So do you notice that ab by 2, if I retain on one side as half ab and take everything else to the other side, what does this give me? This is the area of the triangle, because half into a into b is half into base into height of the right angle triangle. So the area is nothing but 1 by root 3 into, and a squared plus b squared is nothing but the hypotenuse squared. Hypotenuse is 3. So a squared plus b squared is 3 squared by 3, because a squared, I am writing it explicitly, this is Pythagoras theorem. So my area is going to be 1 by root 3 into 3 by 3, which is root 3 square units. So the answer is root 3, option A. Very, very interesting problem. Identify these two as theta 1, theta 2, and then take that the difference between them is pi by 6. Question 11. If z is a non-real complex number, then the minimum value of imaginary part of z power 5 by imaginary part of z raised to 5. Okay. Now all the z to the power 5 and all, imagine if you take z as x plus iy, and then by the time you find x z raised to 5, the exam is going to be over. So all these powers we always use the polar form. So z raised to 5 is nothing but r to the power 5 cos 5 theta plus I sin 5 theta. Right? Remember De Moivre's theorem? De Moivre's theorem says z power n can be written as r power n cos n theta plus I sin n theta, where r cos theta plus I sin theta is the polar form of that complex number. Just bring that power inside and multiply the argument. Now from here I get imaginary part of z power 5 as r power 5 sin 5 theta, which is this. Now what will be the imaginary part of z the whole raised to 5? Imaginary part of z whole raised to 5, the imaginary part of z is r sin theta. So r sin theta the whole raised to 5 is r power 5 sin power 5 theta. Therefore we have to find the minimum of the ratio of these two. So imaginary part of z power 5 and imaginary part of z the whole raised to 5 is nothing but r raised to 5 sin 5 theta by r sin theta r raised to 5 sin power 5 theta. Or this is the function. Let us call this as f of theta. Now our aim is to find the minimum of this function. To do that, we go to the same procedure. F dash of theta is 0. This would imply the denominator will become this a ratio of functions. So sin power 10 theta, square the denominator, keep the denominator first, differentiate the numerator, so that becomes 5 cos 5 theta, put a minus, and then keep the numerator and differentiate the denominator. That becomes 5 sin power 4 theta into cos theta. Okay, don't miss this cos theta. So if I were to simplify this by taking sin power 4 theta and cancelling it below, I get sin power, no, this is sin theta and sin 5 theta, sorry, cos 5 theta, sin theta and cos 5 theta minus, and here I have v du minus u dv, and here I have taking 5 and 2 Sine part 4 theta common and cancelling it to denominator, I get sine 5 theta and cos theta. So I have taken a 5 out and cancelled sine part 4 theta, so I get sine part 6 theta here. Take sine part 4 from both. Now what does this numerator look like? Sine theta cos 5 theta minus sine 5 theta cos theta. Simple, sine A minus B. So sine theta minus 5 theta by sine part 6 theta. This is minus 5 sine 4 theta by sine part 6 theta. Alright. So sine part 4 theta is equal to 0. Now this would imply 4 theta is 0 or theta is equal, which is 4 theta can be 0 or pi or 2 pi or 3 pi, 4 pi and so on. Theta should be 0 or pi by 4 or pi by 2 or 3 pi by 4 and so on. Now the ideal thing to find the minimum would be to find the second derivative and see which one of these are negative, right? But let us just substitute these values and see how these terms are changing. First, if I were to substitute 0, this becomes 0 by 0 indeterminate, so it does not touch that. Pi by 4, where I substitute pi by 4 here, this becomes sine pi upon sine pi by 4 past 6. Now sine pi is 0, so this becomes pointless. I'm sorry. We have to substitute these in the original function and see. Okay, f of theta is sine to the power 5 theta, sine 5 theta by sine to the power 5 theta. Now f of 0 is going to be 0. F of pi by 4 is going to be sine 5 pi by 4 by sine power 5 theta. Now this is going to be minus 1 by root 2 upon 4 sine power, so 1 by 4 root 2. Now this becomes minus 4. Then if you go for f of pi by 2, this is going to become sine 5 pi by 2, which is minus 1. Sine 5 pi by 2 is plus 1, excuse me, and sine pi by 2 power 5. Sorry, sine here. So sine pi by 2 power 5 is again 1, so 1. Then what about 3 pi by 5? This becomes sine of 15 pi by 4 upon sine power 5 3 pi by 4. Now this, the numerator is an angle in the, if I subtract 2 pi and 2 pi, if I subtract 4 and 2 pi, I get 7 pi by 4. 7 pi by 4 is in the fourth quadrant. Fourth quadrant sign is negative, so it is minus 1 by root 2. And this is the second quadrant angle, which is positive, so it is 1 by 4 root 2. This will become minus 4 again. So you will see that these values keep repeating, 0, minus 4, minus 1, 1 and so on. And therefore the minimum is minus 4. And we see that occurs at pi by 4, 3 pi by 4, etc. So the minimum of this function is minus 4. So the minimum of the whole thing is minus 4, option B. Here we are avoiding differentiating this once more and then checking which of these functions are positive and negative, because it's going to be also equally difficult evaluating a little more tedious function. Okay, so form the function using the polar form. You get the function as sine 5 theta by sine power 5 theta, and then differentiate this, equate the numerator to 0, and you get the values of theta, and using them you find the values of theta at those points and choose the minimum most. Moving on, question number 12. By the way, all these are periodic functions, right? So the same values will keep repeating after 2 pi and all. Okay. So question number 12. if the coefficient of x power 7 in ax squared plus 1 by bx power 11 is equal to the coefficient of x power minus 7 in ax minus 1 by bx squared power 11 is then both are equal, then a and b satisfy the relation. Very simple. For the first equation, tr plus 1 is going to be, for this equation, 11cr ax square power 11 minus r plus 1 by bx power r. So this is nothing but 11cr a power 11 minus r x power 22 minus 2r by b to the power r and x to the power r. Or further simplifying this, this is a to the power 11 minus r, b to the power r, x to the power 22 minus 2r, minus 3r, excuse me, 22 minus 3r. Now if you have to find the coefficient of x power 7, then 22 minus 3r should be 7, or 3r is 15 and r is 5. So if I put r is 5, I get the sixth term is 11c5 a to the power 11 minus 5, 6 by b to the power 5, and this is going to give me x to the power 7. Okay, so I get this first term for this equation. Now I have to find coefficient of x raised to minus 7 in the other one. Okay, so x raised to minus 7 in ax minus 1 by bx squared the whole raised to 11. Now this also, the rth term would be 11cr ax power 11 minus r minus 1 by bx power squared power r. This also becomes 11cr a to the power 11 minus r by b to the power r into, let me write minus 1 to the power r also, and then x becomes x to the power 11 minus r by x squared. So it's x to the power 11 minus 3r. Okay, now if this has to give me minus 7, x raised to minus 7, coefficient of x raised to minus 7 is going to be, minus 7 should be equal to that 11 minus 3r, or 3r should be 11 plus 7, which is 18, so r should be 6. So substituting r is 6 here, again I get t, excuse me, it's tr plus 1. So t7, that is the seventh term in this expansion, would be 11c6 and a raised to 5 by b raised to 6, because r is 6, 11 minus 6 is 5, minus 1 raised to 6 is 1, and x raised to minus 7. Alright, so if the two coefficients are supposed to be equal, the coefficient here and the coefficient here, then we have 11c5 a to the power 6 by b to the power 5 is equal to 11c6 a to the power 5 by b to the power 6. Now 11c5 is equal to 11 minus 5, which is 11c6. That is NCR is equal to NCN minus R rule. Therefore, both sides, the 11c5 and 11c6 can be cancelled. And then here if you see a to the power 6, a to the power 5. So I get a here. Here I get 1 by b. B power 5 and b power 6. Or ab is equal to 1. So the condition between a and b is ab is equal to 1, option A. This is question number 12. Question number 13. The average of 5 consecutive odd numbers is 61. So let the odd numbers be, first number is k, then k plus 2, k plus 4, k plus 6, k plus 8. First, some 5 consecutive odd numbers. K is the first odd number and plus 2 gives the successive odd numbers. The average is 61. Then the difference between the highest and the lowest numbers. Now the difference between the highest and the lowest numbers is 8. K plus 8 minus k, which is 8. Nothing at all to work in this, just a bit of common sense, right? Of course, if they ask you to evaluate the 5 numbers, then what you obviously do is use this idea. Average is 61. So k plus 2 plus k plus 4 plus k plus 6 plus k plus 8 upon 5 is 61, or 5k. What I mean is the problem is over here, the answer is obtained, but in case you have to find the actual values also, plus 20 is 305. So k is equal to 285 by 3 by 5. So nothing but 57. So the odd numbers are 57, 59, 61, 63, 65. Right? So the difference is again 8. Question number 14. The abscissa of a and b are the roots of the equation x squared plus 2ax minus b squared is 0, and their ordinates are the roots of the equation y squared plus 2py minus q squared is equal to 0. The equation of the circle with AB as diameter. That is, there is a circle AB as diameter. Then this is x1, y1, this is x2, y2. Then the circle is x minus x1 into x minus x2 plus y plus y minus y1 into y minus y2 is equal to 0. So this is the equation with which we have to work. Now they have given us that the abscissae of a and b, that is this x1 and x2, are roots of the equation this. x1 and x2 are roots of this equation. That means x minus x1 into x minus x2 is given to be x squared plus 2ax minus b squared, and that is equal to 0 in itself. And then the same way, the y1 and y2 are the ordinates. So y1 and y2 are the roots of this equation. Therefore y minus y1 into y minus y2 should be the roots of y square plus 2py minus q square. Right? So if the circle is just the summation of these two, then the answer is summation of these two. So the circle's equation is x squared plus y squared plus 2ax plus 2py minus b squared minus q squared is 0. Okay? So x squared plus a squared plus 2ax plus 2py minus b squared minus q squared is 0. So option A, very simple. You don't have to calculate the roots at all. If you know that these x1 and x2 are going to be the roots of this equation, then x minus x1 and x minus x2 is that equation itself. And since that is how the equation of the circle is written, it is this equation plus this equation is equal to 0. B square minus q square. Okay. Let us move on to question 15. A tower of height 60 meters is located exactly opposite to tower T2 of height 80 meters. Total height is 80 on a straight road. From the top of T1, the angle of depression of the foot of T2, that is this angle, the angle of depression means this angle, is twice the angle of elevation of the top of T2. Okay. So basically it means this angle is twice this angle. So this is going to be 20 meters here and this is going to be 60 meters here. Find then the width of the road in between the feet of the towers. This width, which is the same here, is how much? Now it's very simple. From this triangle, let us name them just for the sake of convenience, A, B, C, D. In triangle ABC, tan theta is 20 by x, and in triangle ACD, tan 2 theta is 60 by x, right? And now eliminate theta from here using the tan 2 theta formula, and then you get the answer. We know tan 2 theta is 2 tan theta by 1 minus tan squared theta. Now this is 60 upon x. Now we have tan theta is 20 upon x. So 2 times 20 upon x by 1 minus 20 by x the whole square is 60 upon x. Or to simplify this a little bit, I get 40 upon x into x squared. If I make the LCM here, I get x squared minus 400 is 60 by x. Let us drop all this, make this 2 and 3. So a bit of rearranging here, what would you get? 2x squared is equal to 3x squared and then minus 1200. Okay. So 2x squared is equal to 3x squared minus 1200, or x squared is 1200, which is 400 times 3. Therefore x can be written as 20 times root 3. So the answer is 20 times root 3, option D. Very simple heights and distances problem. Write tan theta, write tan 2 theta and then eliminate theta from both. Question number 16. The area between the curve y is 2x power 4 minus x squared, the x-axis, and the ordinates of the two minima of the curve is. And the ordinates of the two minima of the curve. Alright. So first of all we have to find what are the two minima of this curve and how this curve roughly looks like at least. So what do we get? Y is this, so minima will occur at y dash or dy by dx is equal to 0. Therefore let's find dy by dx. This is nothing but 8x cubed minus 2x is 0, or 4x squared minus 1 into 2x is 0. This gives us x is 0 or x is plus 1 or minus 1 by 2, right? Okay, so there are 3 points. Now which of these are minimum, which of these are maximum? Find the second derivative. D squared y by dx squared is 24x squared minus 2, right? Now at x is equal to 0, d squared y by dx squared will be minus 2. So this is a maxima. X is equal to, let us say, plus 1 by 2 or minus 1 by 2, no problem. Here it is going to be the same. So d square y by dx square is going to be 6 minus 2, which is 4. So these are minima. X is minus 1 by 2 and x is 1 by 2 are the minima. Okay. Now how is this function going to look like? It has two minima, minus 1 by 2 and 1 by 2, and then a maximum at 0, and the curve also passes through 0 comma 0, that is the origin, right? So the diagram should look something like this. That is, at x is minus 1 by 2 and at x is 1 by 2, the curve has two minimum values. I am assuming, I can say that they are going to be equal because you see that this function is an even function. And then here this is x is 0, and at this point the function has a maximum and the curve also passes through that point. So the graph should be like this. It should go here, it should pass through this, that will be the maximum, and then it will fall down again symmetrically and go this way. So what we need is the area between the two minima, that is this area. Okay. So since this area, the whole area lies in the negative part of the y-axis, you integrate it and take the positive value basically. So the area is minus 1 by 2 to 1 by 2, 2x raised to 4 minus x squared dx. So this is an even function, and I am going to take it 0 to 1 by 2, 2 times 2x square x power 4 minus x squared dx, right? And as I told you, since the area is going to become negative, you can have a modulus over the whole thing. So this is going to be 2 times the mod of, the integral is can be evaluated as x raised to 5. So 2x raised to 5 upon 5 minus x cubed by 3 from 0 to 1 by 2 mod, excuse me. So 0 can be dropped, and 1 by 2 here would give us 2 into by 1 by 2 power 5 is 350. So this, sorry, 32. 32 into 5 is 160 minus this is 1 by 24 plus 1 by 80. LCM is 240. 240, this is 3 minus, let's keep the modulus, 2 times mod of 3 minus 10 by 240, or this is 2 into 7 by 240, which is 7 by 120 square units. Okay, so the area is 7 by 120 square units, option B. So here this also is very important to identify how the minimum and maximum are going to be like, because imagine if in this region the graph did not pass through 0 but passes through some other point here, then you have to find the area between this parts, take it as positive, and the area in this area to be negative. So take the mod of only this area. So this integral will be split into 2 pieces, from here to here and then from here to here. Okay, so all those complications. Here fortunately for us, since the curve passes through 0, the entire area lies in the negative y region. Okay, so option B, 7 by 120. Moving on to question number 17. If for a plane x, y, z intercepts are 8, 4, 4 respectively, then we can write the plane very quickly as x by 4, x by 8 plus y by 4 plus z by 4 is 1, or x plus 2y plus 2z minus 1 is 0. Right? Multiply the whole thing by 8, minus 8 is 0. Then the length of the perpendicular from the origin onto the plane. We know the length of the perpendicular from x1, y1, z1 to a plane ax plus by plus cy plus d, cz plus d equals 0. The length of perpendicular or the perpendicular distance is mod of ax1 plus by1 plus cz1 plus d upon square root of a squared plus b squared plus c squared. Right? So let us substitute all that we have. The origin is 0, 0, 0. In our case, the point is 0, 0, 0. Substitute that point here, you get mod of 0 minus 8 by square root of 1 plus 4 plus 4, which is 9, and so this is 3. So 8 by 3 units. So option A, 8 by 3 units. A very direct problem. Question number 18. If f of x is defined as square root of 4 plus ax minus square root of 4 minus ax by x between the regions minus 1 to open interval 0, it doesn't include 0. And including 0, the value of the function is 3x plus 2 by x minus 8. They don't take 0 here because this would be indeterminate, right? Root 4 minus root 4 by 0. And here they take 0. So first of all, what should be the value of a if the function is continuous? That is, it would be continuous if the limit of this function as it tends to 0 is equal to the f of 0. So what is f of 0? F of 0 can be computed from here, right? So that is 3 into 0 plus 2 by 0 minus 8, which is minus 1 by 4. So the limit of this function when x tends to 0, root of 4 plus ax minus root of 4 minus ax by x, this limit should be equal to minus 1 by 4 if the function is to be continuous in this interval minus 1 to 1. So how to find this limit? The easiest is L'Hospital's rule. Differentiate the whole thing. Then differentiate the numerator and differentiate the denominator, because it's a 0 by 0 form. Okay. So if you differentiate the numerator, limit x tends to 0, it becomes 1 by 2 root 4 plus ax into a minus 1 by 2 root 4 minus ax into minus a by 1. Now this should be equal to minus 1 by 4, let's keep it there. And put x is equal to 0 here and see what happens. If x is 0, this becomes a by 2 into root 2, right? X is 0. So 2 into 4, root 4 is 2. So 4. Minus of minus a is plus a. And here it is again 2 into root 4, which is 2, 4. So a by 2 is minus 1 by 4, or a is minus 1 upon 2. Okay, so option D, a is minus 1 by 2. Now this limit can also be, this limit we have done using L'Hospital's rule, differentiate the numerator, differentiate the denominator, which is quite simple in this. When the terms are not very complicated to differentiate and just the one differentiation is going to give you the proper answer, then this is the best method. Otherwise you can do the rationalizing the numerator also. What I mean is, limit x tends to 0, square root of 4 plus ax minus square root of 4 minus ax upon x. You take this as a, take this as b, and a minus b is going to be written as a squared minus b squared by a plus b. So the whole thing can be written as limit x tends to 0, 4 plus ax minus 4 minus ax by square root of 4 plus ax plus square root of 4 minus ax, right? What I've done is a squared minus b squared by a plus b into x. So in the numerator 4 minus 4 is gone and I have 2ax, which can be cancelled with the x here. So limit x tends to 0, I have 2ax by square root of 4 plus ax plus square root of 4 minus ax into x. So x tends to 0, this becomes 2a by root 4 plus root 4, which is a by 2, which is the same as the limit we got earlier, a by 2. Okay. So any method, the answer here is minus 1 by 2. Question number 19. The relation R defined in the set 1, 2, 5, 6 is a and b are related if b is equal to a plus 1. So we have to check whether it is reflexive, symmetric, all that. Now if you see a related to b if b is equal to a plus 1. Now can a be related to a? That would mean a is equal to a plus 1, which is a contradiction. No. So it is not reflexive. A related to b, does it means b is a plus 1. But b can be related to a should mean a is b plus 1. Now both this cannot be true. So it cannot be symmetric. Transitive, a related to b implies b is a plus 1 and b related to c implies c is b plus 1. Therefore, c can be a plus 2. So it is not the same relation. So it is not transitive also. So it is neither reflexive nor symmetric nor transitive. Option A. Very simple. Question number 20. Integral of sine power 8x minus cos power 8x by 1 minus 2 sine squared x cos squared x dx is. Now this is quite simple. Just decompose the numerator. Let us work on the numerator for the time being. Sine power 8x minus cos power 8x can be written as sine power 4x plus cos power 4x into sine power 4x minus cos power 4x. Now this is like a squared plus b squared. So it can be written as a plus b the whole squared minus 2ab. A is sine squared x and b is cos squared x. Okay. So this is sine squared x plus cos squared x the whole square minus 2 sine squared x cos squared x. Okay, this is the whole term. What about this term? This can be continued to be written as sine squared x plus cos squared x into sine squared x minus cos squared x. It is still a squared minus b squared form. Now this, luckily, this becomes 1. This also is 1. So it is 1 minus 2 sine squared x cos squared x into sine squared x minus cos squared x. So this is the numerator, correct? Now, if you substitute the whole thing here, the integral becomes 1 minus 2 sine squared x cos squared x into sine squared x minus cos squared x upon 1 minus 2 sine squared x cos squared x. Now these two terms can be cancelled and all I have is integral sine squared x minus cos squared x dx. This is nothing but minus of cos 2x dx. And this integral becomes minus sine 2x by 2 plus c. So the answer is minus half sine 2x plus c, option B. Very simple, just factorize and use the basic trigonometric identity. Sine square x plus cos square x is 1. This brings us to the end of the objective part. Now we move on to the subjective numericals. The first one, let p of x is equal to x squared plus bx plus c, where b and c are integers, both are integers. Px is a factor of both this and this, okay? Then the value of p of 1 is, they said that p of x is a factor of, let us call this as f of x and let us call this g of x. Now p of x is a factor of this, which means it can divide this. P of x is a factor of this, which means it can also divide this. So p of x should be a factor of any linear combination of these two. So I am going to make a nice trick of doing gx minus 3fx to eliminate the x to the power 4. We can say that if p of x is a factor of f of x and p of x is a factor of g of x, p of x is a factor of this also, is divisible by p of x. Okay. So what does this give me? 3x power 4 plus 4x squared plus 28x plus 5 minus 3x power 4 minus 18x squared minus 75. Correct? 5 and 75. Okay. Minus 3f of x. Now this gives me, after cancellation of these two things, what do I get here? Minus 14x squared plus 28x minus 70, or minus 14 times x squared plus minus 2x, minus 2x plus 5. So if p of x is a factor of this, this is divisible by p of x, then it means p of x is equal to x squared minus 2x plus 5. So we see b and c are minus 2 and 5. Okay. Now the question is, what is the value of p of 1? Nothing but 1 minus 2 into 1 plus 5, which is 4. So the answer of p of 1 is 4. Okay. Very simple. We use the idea that if it is a factor of both f of x and g of x, it is a factor also of a any linear combination, any constant. It is a factor of 10 g of x minus 20 f of x. You understand? Our advantage here is to eliminate that x power 4 terms, and then we get a quadratic expression, and since that is a factor, we say that this must be p of x, because there is no other factor here. Okay, question number 22. There are 8 rooms on the first floor of a hotel with 4 rooms on each side of the corridor. Okay, there is a corridor. There are 4 rooms each side of the corridor, symmetrically situated. That is, each room is exactly opposite to one other room. So there are 4 rooms here, let us say, and there are also 4 rooms on the other side of the corridor. Alright. So let's call this room 1, 2, 3, 4, 5, 6, 7, 8. 4 guests have to be accommodated in 4 of the 8 rooms. That is, 1 in each, such that no 2 guests are in adjacent rooms or in opposite rooms. Okay. If n is the total number of ways in which the guests can be accommodated, then the value of n by 6 is very simple. You see, the guests cannot be opposite or adjacent. So the guests can be here, here, here and here, or the guests can be the same way. They can be in rooms 5, 2, 7 and 4. Right? Either this way or this way. The 4 guests can be here. These are the only possibilities. So if you choose these 4 rooms, that is rooms 1, 3, 6 and 8, these 4 rooms, the guests can be arranged in these 4 rooms in 4 factorial ways. 4 guests, 4 rooms, 4 factorial ways. If you choose rooms 5, 2, 7 and 4, there is another 4 factorial ways of arranging. 4 factorial is 24 and 24. So the total number of ways n is 24 plus 24, 48. So n upon 6 is 48 upon 6, 8. So the answer is 8. Okay, very simple permutations combinations problem. Question number 23. Let f from 1 to infinity be to 2 to infinity be a differentiable function such that f of 1 is equal to 1 by 3. If and they have given a differential an equation, if integral 1 to x f of t dt is equal to 3x f of x minus x cube for all x greater than or equal to 1, then the value of 3 times f of 2 is. Now we have to convert this to a differential equation, so we use that differentiation under the integration rule. You remember that? That is, if you are differentiating something with respect to x, an integral which is like this. The limits are also functions of x and the integrand is a function of x and t dt. So the integral is with respect to t, and then finally when you substitute g of x etc. So it becomes a function of x which can be differentiated. So this can be written as integration, differentiate this with respect to x. Strictly speaking, this is a partial derivative. Remember, we did this a problem like this in the first NTA test. And then there are 2 other terms. The other term is, the other term is not an integral. The other terms are based on the limits. That is, you substitute the upper limit in the function in the place of t, g2 of x, and differentiate that g2 of x. And third term is subtract. You substitute g1 of x in the function and you subtract it from the product of the derivative. Alright. So in our particular problem, you see that the function is not a function of x at all. So this is going to become 0. And the lower limit is 1. So this is going to become 0 also. And the upper limit is equal to x, so this differentiation is 1. Okay. So for our particular case, d by dx of integral 1 to x f of t dt will have only this term, which will be substitute the upper limit in the place of t, so f of x, and differentiate it, it is 1. So this is f of x. So differentiate both sides with respect to f of x. Let us differentiate this integral f of t dt as 3x f of x minus x cube. If you differentiate with respect to x, this becomes 6 into, as we have shown that the derivative is just f of x, 6 into f will be 3 times x into f dash plus f into 3, if you different product rule, minus 3x squared. Or this can be, after some simplification, bring the terms over, rearrange these things. So 6f minus 3f is 3f minus 3x f dash is minus 3x squared. Okay, or you can say f minus x f dash is minus x squared. Let's continue on the next page. F minus x f dash is minus x squared. Or if I bring the x squared to this side also, this equation becomes like f minus x f dash by minus x squared is 1, or x f dash minus f by x squared is 1. Now see, this looks like x squared here, keeping x, differentiating f as f dash, and then minus keeping f and differentiating x, which is 1. That is, this is nothing but the derivative of f by x. Right? How would you differentiate this? Square the denominator, keep the denominator, differentiate the numerator, minus keep the numerator, differentiate the denominator. So now integrate both sides. On the left hand side, you get 1 dx, or this becomes, if you integrate on both sides, f by x is equal to x plus c, or f becomes x squared plus c, cx, excuse me. They have given us one condition, that is f of 1 is 1 by 3. So that substituted here becomes 1 by 3 is 1 plus c, or c is minus 2 by 3. Therefore f is x squared minus 2 by 3x. Right? And the final thing we have to calculate is 3 times f of 2. So how much is f of 2? It is 4 minus 2 by 3 into 2, which becomes 4 minus 4 by 3, or 8 by 3. So 3 times f of 2 is 3 times 8 by 3, which is 8. So the answer is 8. Quite simple. Differentiation under the integration rule. And since the integration is also not very difficult, it's the problem becomes very simple. And you get a normal differential equation which you can solve. Let us go to the last but one problem. Y is tan inverse of secant x minus tan x. Then the value of dy by dx is how much? Everything depends on how we simplify the terms inside. So let us work on that. Secant x minus tan x can be written as 1 by cos x minus sin x by cos x. Now this is nothing but 1 minus sin x by cos x. Now this is nothing but, this is usually simplified like this: cos squared x by 2 plus sin squared x by 2. Right? 1 can be written as sum of cos squared and sin squared, because this x by 2 allows us to write this sin x as 2 sin x by 2 cos x by 2. I am using all half angle formulas. And cos x becomes cos square x by 2 minus sin square x by 2. So you see, what we have in the numerator is cos x by 2 minus sin x by 2 the whole squared. And in the denominator I get cos x by 2 plus sin x by 2, a plus b into a minus b. So cos x by 2 minus sin x by 2. Now these two can get cancelled, and what I will get is cos x by 2 minus sin x by 2 by cos x by 2 plus sin x by 2. And if I take cos x by 2 common from the numerator, I get 1 minus sin x by 2 by cos x by 2 by 1 plus sin x by 2 by cos x by 2. Right? So this becomes 1 minus tan x by 2 by 1 plus tan x by 2. This is nothing but tan pi by 4 minus x by 2. Right? Do you remember this? Tan pi by 4 minus x by 2 is tan pi by 4 minus tan x by 2 by 1 plus tan pi by 4 tan x by 2. And since tan pi by 4 is 1, it comes to this neat form. Therefore, y is tan inverse of tan this. So y is tan inverse of tan pi by 4 minus x by 2. This becomes pi by 4 minus x by 2. So the derivative of y is nothing but minus 1 by 2. Right? So the answer for this problem is minus 1 by 2. Very simple. Just a little bit of simplification. Let me tell you another way of simplifying the same thing. That is the secant x minus tan x. We wrote as 1 by cos x minus sin x by cos x, and was 1 minus sin x by cos x. Now this can of course be written as 1 minus cos of pi by 2 minus x by sin of pi by 2 minus x. If you consider this whole angle as theta, then 1 minus cos theta is 2 sine square theta by 2. So it is nothing but 2 sine square this angle by 2, which is pi by 4 minus x by 2. And the same way, this is nothing but 2 sine theta by 2, which is the half the angle, minus x by 2, cos of the same thing. Right? Now again here 2 and 2 are gone, sine and 1 sine are gone, and you get tan of pi by 4 minus x by 2, the same thing that you got, tan of pi by 4 minus x by 2. So this is also another way in which you can do. All this is just to show that there are always different ways of doing. Be confident and follow the rules of mathematics, you will never go wrong. The last problem. The volume of a cube is increasing at the rate of 18 centimeter cube per second. So let us write it down. They have given us dV by dt is 18 centimeter cube per second. When the edge of the cube is 12 centimeters, let us say A is 12, then the rate in centimeters squared per second at which the surface area of the cube increases is, question is ds by dt is how much? Okay. Okay, now these things are very simple. Volume is nothing but a cube. So dV by dt is nothing but 3a squared dA by dt. So substitute whatever we know here. 18 is equal to 3 into 12 into 12 into dA by dt. Now this would give me dA upon dt is equal to 18 by 3 into 12 into 12, and I know this is 2 times, so 1 by 24. Now surface area is 6a square, right? So ds by dt is nothing but 12 into 12a times dA by dt. Now substitute them again. 12 into a is 12, dA by dt is 1 by 24. So it becomes 2 and 6. So 6 centimeters square per second. So the answer is 6. Very simple problem based on the application of the derivatives. This brings us to the conclusion of NTA's test paper number 5. See you again with NTA test paper number 6. This is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad.